This is our second part of our video on rational and polynomial inequalities. In this question, it says solve the following rational inequality graphically. And it gives us the inequality x plus 2 divided by x minus 2 is less than or equal to 5. So there are a lot of different ways of doing this, but we are going to try to do it using our graph. So we are going to take what's on the left side of the function, that's the x plus 2 over x minus 2, and we are going to graph that. And then once we have our graph, we're going to look at where is our graph less than or equal to 5. So I'm going to start with y equals x plus 2 over x minus 2. So if you would like to try graphing this on your own, right, and then just kind of check back in on the video to see the second part, I would recommend that. But if you need help with graphing, I am going to go through that right now. So first thing I usually do is I try to factor, but there really isn't anything to factor in the numerator or denominator. I look to see if there is anything that cancels from the top and the bottom, and there is not, which tells me my graph does not have any holes in it. Then I'm going to move on to my y-intercepts. We get our y-intercept by taking x and setting that equal to 0. So I am going to calculate. So y equals 0 plus 2 over 0 take away 2. That's going to give me 2 divided by negative 2, which is negative 1. Okay. Then we're going to do our x-intercepts. We get our x-intercepts by setting the equation equal to 0 and solving, but a shortcut with rationals is just to do the numerator and make that equal 0. So I'm going to take x plus 2 and set that equal to 0, and then rearrange to get x equals negative 2. Okay, that took care of our intercepts. Now we need to do our asymptotes because this is a rational function. So it has a denominator, so it should have asymptotes. For the vertical asymptotes, we look at what makes the function undefined. So what makes the denominator 0, dividing by 0 would make it undefined. So I'm going to set x minus 2 equal to 0, and then rearrange to get that x equals 2. And then for horizontal and oblique asymptotes, I look at my numerator and my denominator, and I look at the highest exponent. If the highest exponent is on the top, it's oblique, and if it's not, it's horizontal. So here I have x, or x to the 1 on the top. I have x to the 1 on the bottom. They're actually the same exponent, so therefore it is a horizontal asymptote. So I do not have an oblique. All right, for my horizontal asymptote, you can either do long division and divide x minus 2 into x plus 2, or we can do a little bit of a shortcut and just divide those first terms. So x divided by x is just 1, so this would be y equals 1. All right, last thing I need is a sign chart. So for our sign chart, we are going to take everything that has an x, which would be my x-intercepts and vertical asymptotes, and we're going to put those on a number line. They need to go from lowest to highest. So I'm going to do negative 2 first, and then positive 2. Now we have options we've talked about. You can break it up into its individual pieces and then figure out the overall sign. You can just do it all in one step on your calculator. It is entirely up to you. I think today I might do one step on my calculator. If I'm going to do the one step though, I need to make sure that I am putting brackets around the numerator and brackets around the denominator so that my calculator understands what I'm doing. Sorry, I'm just trying to find my calculator. Okay, so I need to choose some test points. So I'm going to pick a number less than -2. So maybe -3. A number in between -2 and +2. So maybe 0. And a number bigger than 2, maybe 3. And then I'm going to sub those numbers into our equation. So I'm going to do bracket x plus 2. So -3 plus 2, close bracket, divided by bracket, and then x minus 2, so -3 minus 2. And I got 0.2. I don't care about the number, I just care that it's positive. Okay, 0. So I'm going to do 0 plus 2 divided by 0 minus 2, which is -1. So I know that's a negative. And then I'm going to do 3. So 3 plus 2 divided by 3 minus 2 is 5, which is positive. Okay, I'm going to take all of that information and we're going to create our graph of what this function looks like. So there are no holes, but we have a y-intercept at -1. That would be here on the y-axis. We've got an x-intercept at -2. We have a vertical asymptote at +2. I should use a ruler. I'm just going to try to go for it here. And then we have a horizontal asymptote at 1. Okay, I need to figure out what my ends are doing. So I start with my vertical asymptote at +2. So I look in my sign chart at +2 and I try to figure out what it's doing on either side. So on the left side of the asymptote, it says minus. So I'm going to follow on the left side the asymptote down. On the right hand side, it says plus. So we're going to follow that asymptote up on the right hand side. Okay, for the horizontal asymptote, I only worry about the far left and far right. So on the far left, it says plus. So the y values here have to be positive. Now, if I follow it on the top or I follow it on the bottom, it's still going to be positive. So I look to see what else I have. I notice that the 2 intercepts and the other arrow are underneath. So I'm going to assume that it stays underneath. On the other end, right, same thing. If I look at my chart, it is supposed to have positive y values. It doesn't matter which side of the asymptote I'm on, they're going to be positive. So I look to see what else I have. I notice there's another arrow that's on top of that asymptote. So I'm assuming that we're going to stay on top. I don't know for sure, we're just making an educated guess. Okay, so when I go to draw this in, I'm going to look at one side of the vertical asymptote and then the other. I'm going to cover up this side. I notice on this side of the asymptote, we've got the arrow, a point, and the arrow. So we are going to try to connect those together. And then on the other side of the asymptote, I've got arrow and arrow. So I'm going to try to connect those together. And there is the sketch of my graph. Now, we sketched the graph so that we could do the inequality. So I am going to go back up to the top, and it said we were looking for where x plus 2, x minus 2, which I just graphed, is less than or equal to 5. So we're talking about the y values. I'm going to find where 5 is. 5 is here. So less than or equal to 5, well, it equals 5 here. So I'm going to make a dot. And then less than means everything's smaller than 5. So we're looking at all our y values smaller than 5. So that would be this section here has y values smaller than 5, as does this section here. Okay, so we need to state the intervals. I can do this section, that's not a problem. But when I go to do this section, I don't actually know where that point is. I could kind of look off my graph to estimate, but my graph is pretty sketchy. It's not exact, so I don't really know what the y value is. Right, I know what the y value is. I don't know what the x value is that matches up with 5. So I need to find that point. And in order to find that point, we are going to have to do a little bit of math. I am going to take x plus 2 over x minus 2, which is the graph that I made, and I'm going to try to figure out where does it equal 0. So I'm going to take x plus 2 over x minus 2 and set that equal to 5 so that I can try to figure out what the coordinates are of that point. So this is just a rational equation. I am going to solve by cross multiplying. So I put the 5 over 1, and then I do 1 times x plus 2 is x plus 2. 5 times x minus 2 is 5x minus 10. And then I am going to solve using my grade 9 solving skills. I'm going to bring all the x's to one side, so I'm going to take x away to get 2 equals 4x minus 10. I'm going to add 10 to both sides to get 4x equals 12. And then divide both sides by 4 to get x equals 3. So I know that this point is the point 3 and 5. It might not look like it on my graph, right? It might look like it's at 4 or 3.5, but it is actually at 3 and 5. So that means the regions where x plus 2, x minus 2 is less than or equal to 5 is this section here. So we're always doing our x values. So it's from negative infinity to our asymptote at 2. Infinity never gets an equal sign, so I'm doing a rounded bracket on that. Asymptotes also don't get equal signs, so I'm doing a rounded bracket on that. This section starts at 3 and continues to infinity. So this goes from 3 to infinity. I do actually have a point at 3, so I do a square bracket, and then infinity is not really a number, so I do a rounded bracket. And then I unite those two sections together. And that is my final answer for where x plus 2 over x minus 2 is less than or equal to 5. All right, good luck on your homework.